Hello and welcome to this ETSI webinar dealing with a review and demos of the OSM Release 8. My name is Gavin Craig and I'm a Senior Technical Content Officer at the ETSI Secretariat and will be your moderator today. This webinar will provide an update on the status of ETSI's open source MANO project and its latest achievements, including 2 live demos showcasing the new features in the end-to-end deployment of a mobile network service based on Magma EPC. The speakers today have all played an active role within ETSI open source MANO and are therefore well qualified to give this webinar. Before I hand over to the OSM Chair, Francisco-Javier Ramon, to start this webinar, I'd like to remind you of some quick points about the webinar today. A recording of our webinar will be made available on demand a few minutes after we've ended it at the same location as where you are right now. Also, feel free to ask questions at any time by clicking on the Ask a Questions button. We'll handle questions at the end of the webinar, but if we don't answer your question, don't worry. We'll get back to you after the webinar by email. We've also attached the slides in PDF form and other useful information which you can download from the Attachments button. You can also share this webinar using the social media buttons above the viewer and rate it with a Rate This button. Now over to you, Francisco-Javier.
Thank you, Gavin. So, welcome everyone to the OSM Release 8 webinar. We wanted to give you an update of what's been the main things that OSM as community has achieved in this past release cycle, and also trying to illustrate them with some demos, as Gavin explained in the introduction. But first of all, I think it's good because not everyone is on the same page and not everyone has attended past webinars what OSM does at a high level. So you can follow better the next sections more specific to Release 8. So it will be a quick introduction. What OSM provides is a platform to create network services on demand, right? To manage them later in a convenient manner. Okay, this is what OSM does. As you see, I mean, OSM does not do this task alone. It requires obviously orchestrating all the platforms that do other things, less complex things on demand. Obviously you need to interact with beams, with SDNs, even with some the own applications that you are running, and OSM builds from the bottom to up the end-to-end complexity, right, of all that it goes and exposes an interface to be operated, right, and that is based on Sol 5 in CNV Sol 5, so you can drive all these operations programmatically if needed. Okay. More on that. I mean, what we mean by different type of infrastructures, and what we mean is that OSM supports multiple technologies of beams and multiple technologies of SDN. So regardless of their differences among them, and in terms of the specific calls, the sequence of the calls, etc., etc. I mean, OSM takes that, absorbs that complexity and controls it via this plugin model. So the operations from OSM level are transparent regardless what specific technology of that set you have. And at the same time, you can operate this in a distributed fashion. So you could have several sites with different technologies, or even different technologies in the same site, but from this point of view is pretty much the same. And OSM allows you to coordinate them all and build network services across them. Okay. This is important because right now there is not one single technology either for virtualizing components or even to build a network function, right? So traditionally, when we were talking about NFV, we were talking about VMs, and that's the vast majority of BNFs today, commercial BNFs, I mean, are running in VMs, right? It doesn't mean that there might be other applications that do not run in VMs. That's clear that there aren't. But I mean, it was the previous normal was that. But also, you need to incorporate new technologies that are hot right now, and you see commercial products on them. So, for instance, many network functions are coming in as containers, right? So you need to operate them from OSM, right? You might even include some components that are physical in your network service. Sorry, you need to take them into account. And something very interesting that we are seeing emerging is that there might be some components, network functions, that are comprised of a combination of those elements. So, but they have a common life cycle, right? So all those combinations, which essentially are any possible combination of technologies as of today, are supported by OSM. So OSM will allow you to drive effectively, to treat effectively all these kinds of workloads and the description of these workloads, and life cycle of these workloads, with no need of anything extra, right? Well, the thing is that, well, obviously, I mean, there is a large number of applications that come mostly from the IT environment, or seem like workloads from the IT environment. I'm thinking right now on a AAA or a DNS or equivalent, but not necessarily all the workloads, as you know, are of that kind. Many of them have requirements in terms of the data plane, how the resources need to be allocated, how you minimize interference in the use of those resources, etc., etc. And that is pretty obvious for data plane intensive, the IO intensive applications. So OSM is equipped with all that you need to do that. So this is not an issue, does not require any exception in the procedures that I'm about to describe, right? So the philosophy here is about modeling, right? OSM is model driven, and this is one of the main. Probably if you are new to OSM, this is one of the main ideas that you need to get out of this webinar, because everything in OSM is modeled, right? So you can make it portable and reusable, so OSM can work on the details of the different specific technologies that you might have underneath, right? So you are defining your BNF, and in your BNF you define a BNF package, right? I'm saying network function package because it's not strictly, I'm not talking strictly about VMs or about containers or about physical network functions or about hybrid. It could be any of them. There's no fundamental difference from OSM perspective. You are modeling a package. Typically this is provided by the vendor. It's not mandatory, but typically. And what you have is the description of the topology, what is inside. What are the parameters that you can touch, right? And so they are exposed, and all the potential actions for day 0, day 1, and day 2, right? All that is modeled and described. So the trick here is that the provider doesn't need to know the details about your target infrastructure. In principle, that is already in the model and is encapsulated in the model, and OSM will take care. And they not even need to know for a specific network function, the other components that will be part of the scenario, that will belong to another layer in the modeling that we'll see right after, right? Are the network service packages or even the slice packages, which are similar, not strictly the same thing, but well, for the interest of this introductory level, I think it plays an equivalent role, right? Is the way that you combine those models as if it were a blueprint. You say how you combine these orange components, these blue components, and this purple component or pink component. How do you combine them to build something that makes sense, right? And again, you are describing here the topology, but also the day 0, day 1, etc. Right? So it works as a system, a network service, right? It's what OSM provides. So this in practice so far what we have done is modeling, right? We have not created anything yet in the cloud, but that comes right after. It's the immediate step right after. So once you have this collection of packages loaded, these blueprints that I meant before, then you can particularize it in an instantiation. This is where you actually create the components and allocate the resources. And you can use the same packages over and over to create different instances in different places. And moreover, you can put different parameters, those parameters that I mentioned that were exposed, you can customize those parameters for each of the deployments in case that, for instance, you need to use different addressings for each of them, or you need to provide different type of credential sets for them, or attach them to different subsystems there. Say that you have an NTP server that is different in the 3 locations, right? So you might want that there is a parameter and you could change it upon instantiation time without conditioning your package, right? So this is the beauty of having it in a package that is 100% replicable, right? And you are not taking into account anymore on the details of each of the subcomponents, right? So the package, as you have seen, is a key here, right? It's a key element in OSM, and you will see a lot in the demos, by the way. So the thing is the following. The keys are 3. One is that it's agnostic to the infrastructure. We are not hard-coding technology-specific information there. So it doesn't need that. The advantage is that you don't need to know the details of the infrastructure of upfront. So for instance, if you are the developer of applications, you don't need to know, and you have a prospective customer that has OSM, you don't need to know the details of that infrastructure, because in the end, that will be managed by the OSM models internally, right? You don't need to model that. It will include also the life cycle, so you don't need to bypass the logic that has been created by the operator. So you are enforcing a best practice all the time, and as I said, it can be easily customized upon instantiation. So you can even that you have a strict way of working. You can add the flexibility, all the flexibility that you may need just by parameters that you can set at the very last minute. Okay. And last, so how does it work in practice? As I mentioned, that OSM MBI that is based on ETSI NFV ISO 5. I mean, it's the key. It's how you use the system. All this complexity, how you communicate with OSM, is via this northbound interface, and this northbound interface is accessible from different means. I mean, it's an API after all. So OSM has, of course, some client applications that doesn't preclude that you might interact directly with the OSM's API from an OSS or a VSS. But that said, I mean, OSM provides already some client applications to use it more conveniently. We add a GUI, OSM GUI that will see an update. This is one of the things that have been significantly updated in Release 8, but also the OSM client, I mean the CLI. So for automation of tasks is usually more convenient, obviously, as always, and you can have an OSS or a VSS directly attached. The point is that the coherency is maintained in OSM, so you are not keeping any logic, any hard-coded logic in the GUI or in the client, that whenever that command has been submitted to the OSM API, the consistency is managed inside OSM. So that guarantees also the authentication, the consistency with authentications, all the RBAC policies, and the authorization of actions, all the roles that you want to enforce, the projects that you have, the users in the roles of each project, etc., etc. All that is managed internally in OSM. You don't need to hard code it northbound. The context of visibility that each of those projects have, the state of the system, etc., etc. So you have light clients that interact with OSM via the northbound API, and we'll see a lot today about this. Everything that you will see happening, obviously we'll see it happening in the GUI on the client, because it's what it is. It's human friendly, but it's not. But what happens underneath is a communications with OSM's MBI that guarantees this consistency. Okay. So what provides OSM Release 8? Release 8 brings a lot of new features. I mean, this is a subset of them. So this I don't want it to be too verbose here, but I mean, there have been many improvements in the catalog of examples and DNFs that we are providing, illustrating all the functionality. I think this is key, and they are exposed, and we'll see a lot about that. But also, I mean, there's been improvement in usability. As I said, We have created a new user interface, a graphical user interface. So that's been totally changed. I mean, the usual the usual procedure for those who are been using OSM Release 7, you see that it's familiar for you, but the UI is quite different. Underneath, there are been many improvements in the onboarding workflows. You can consume directly packages from a Git repository. You can use on-the-fly packages of EPA and non-EPA. That was a consistent source of duplication. It's very important. This release has readiness for high availability deployments in some components that were missing, and now we have that clarity, and I see that this is great, that minor gap has been filled in Release 8. Also, the data, the internal data is now better exposed. You have quotas per project, so you can even limit the resources per project inside OSM. And also, there's been a massive improvement in the way that we collect the metrics. We have a dedicated demo slot for that, so I won't elaborate more on it. We've incorporated new installation options, so we can have some flexibility on the way that we wanted to deploy, either more complex, more simple, with redundancy, non-redundancy. This for the community. I mean, so this is free and available for everyone. And there's been the addition of 2 new technologies that are supported by OSM. One is a plugin for Arista Cloud Vision, and the other is for Juniper Control. So both are now formally supported. So as SDN technologies in OSM. So I think that this is it goes in the policy of incorporating new relevant technologies that could be abstracted by OSM, so you don't need to model specifically for them. Okay. Well, and all this cannot happen, I mean, with a small group. We are quite happy with the adoption and the traction. I mean, OSM is 140 members today, open to new participants, as we always say, and I think that this is great. I mean, we are in a very healthy environment, and we have the recent incorporation of Fujitsu and ICCs, if I remember well. So I mean, we keep, the community keeps growing, and what is more important than the number, the figures that are quite significant, is also about the quality of the participation. So I think that we are quite happy with this, and we need to remain open for new type of technology stakeholders. All right, and regarding the OSM ecosystem, which is this list is slightly different in view on what is the traction of OSM, is the list of products that are offered and that are related to OSM, either because they are based on OSM or because they can explain how it is compatible and works flawlessly with OSM. So it's like the OSM yellow pages. This is continuously open, so I mean, you might see some changes in the time in this list, but this is the tip of the iceberg of the kind of technology map that you can find, right? So well, the map, as you see, that we have different categories. Almost all the pieces of the stack have covered one way or the other. If we have 4 distros of OSM and a number of consulting and integration partners that can set up an OSM for you. It clearly, I mean, this is the direct use of the technologies and direct commercial use of the technologies, but also there's a large number, as you see, of BNFs and BIMs that are formally supported OSM and business systems that successfully interact with OSM. There are training offers, there's even research organizations that can provide also resources about OSM. So I mean, and this is the, as I said, this is not exhaustive, this is the tip of the iceberg, but it's significant enough. Okay. And this is it. I mean, this is For the introduction, what we'll tell you right after this introduction is first are two demos, focus on different parts of this, the novelties of the later release of OSM. One is what are the system features, are the things of OSM as platform that are relevant for OSM as platform. So Guillermo Calvino from Canonical will tell you about the high availability, the next generation of user interface, the user interface that we have in OSM, the system quotas, how they work. Then the system monitoring, I believe that will be Gianpietro who will take that part. I mean, so that will be part of the system related features, but also we'll see in action the capabilities in terms of the use of the use cases, how you can support use cases, the deployment of BNS from a catalog, the use case of Magma that illustrates almost everything that is available in OSM, to be honest, and also the use of high performance network functions. So what are the techniques that OSM puts in place in order to deploy successfully a special BNF of that kind. And all those sessions will be driven by Gianpietro Lavado from Whitestack. Okay. So well, that was it. But I was about to say that that's not it. I mean, obviously there are many other things that are relevant about OSM. We can summarize them in a webinar. We are totally aware that there may be too much information that we are giving to you today. But we're trying to be careful on selecting the material still. But in case that you want to master OSM, you want to understand what it provides, you want to see an early preview of new features that are coming for all that you can, it's like the okay, now my microphone is back. Okay, so I was saying the best place is an OSM Hub Fest. The next one is on November 20th. So and takes 4 or 5 days. So my recommendation is that you register early, so we can see the figures. The logistics is complex, but definitely this is the best place to learn about the OSM, how to use it in practice, how to run examples, etc., with the best instructors that the OSM community, even the own developers. So this is great. Okay. So that's all. I will pass the control to Guillermo Calvino from Canonical, who will tell you about OSM system features. So over to you, Guillermo.
Thank you, Francisco-Javier. Hello, everybody. My name is Guillermo Calvino, and I'm going to present some of the latest features that have been achieved in OSM Release EIGHT. We have selected these ones that we consider relevant, like high availability, next generation UI, system quotas, and system monitoring. And during this presentation, as Francisco-Javier mentioned, we are going to show some demos of all of them. So first, we are going to talk about high availability. OSM is now high available. This has been achieved thanks to the use of Docker Swarm or Kubernetes for its installation, and the use of redundancy of the OSM component. The use of Kubernetes allows us to maintain the state of the different OSM applications. So if we define that an application must have one pod running and this pod fails, Kubernetes will create a new pod automatically. Additionally, OSM provides redundancy, where more than one pod of each application is deployed. Note that all these features have helped a lot to improve OSM's resilience, and this is key for production deployment. During the demo, we will show how OSM behaves when there is a failure of one of the pods. We will simulate this, forcing a deletion of the pod itself. And also we will show one feature called high availability proxy charms, where we will create a network service with a proxy charm in ETSI. The proxy charm will be in charge of operating the network service. So it can handle the lifecycle management of the BNF. Okay, so there are many possibilities when it comes to install OSM, as also Francisco-Javier saw. There are now new methods of installing OSM. It can be installed in many ways. Each of it has their own handful of options. And for this demo, we are going to use the Charm installer, a production-ready installer that provides built-in HA, backups, upgrade capabilities, and the ability of lifecycle management of the installation, being able to scale or configure each OSM element separately. This installer can be used just adding the Charm option to the installer script. So the options that we need to specify for the high availability installation are the following. We have the --charm to specify the Charm installer, and also the --HA because we want to make our installation high available. If we use only these options, OSM will be installed in HA, but just in one node. And this can make sense for development purposes. In a production environment, it makes sense that OSM uses already existing infrastructure. For that, we would need to provide the credential of the cluster we want to use. So the rest of the parameters we see here are to define the, for instance, the LST cluster, or the VCA that we are going to use, or the case cluster that we will need to provide the kubeconfig file. So now I'm going to share my screen. Let me Okay, and we're going to start the HA, the high availability demo. The first thing I want to show is the command I use for the installation. Well, as you can see, I have used external cluster simulating an installation in a production environment. So I have provided OSM the details of the underlying infrastructure that it will use. Now we're going to review the installation, and first we're going to check the status of the OSM elements in the case cluster. We will use status for that. So as you can see, all the applications are in active state, and you can see also that we have 3 units of each, so they are in HA. Next, we are going to check the pods. For that, we will use the QCPL command, and you can see that all the pods are running. So you can see here also that there is an operator pod for each application. This operator is in charge of create, configure, and manage the instances of the applications on behalf of a Kubernetes user. Okay, so we have checked the different status of the different OSM applications that run in Kate, and now we're going to check the status of the VCA cluster. For that, we will change the model that Juju is checking to the controller 1, and we will check the status. As shown, you can see here that we have the VCA running in 3 different VMs in HA. Okay, so let's go again to the OSM model. And now that we have checked the OSM installation itself, let's play a little bit. So for that, we are going to monitor one application, and we will delete one of the pods that is in that application. So we're going to monitor this application with the PLA. And now just let's delete the pod. Let's look for the PLA pods, are these ones. And we are going to delete, for instance, this one. Okay, as you can see, a new pod is being created and initialized. OSM uses a declarative deployment from Kubernetes, where we define the pods that OSM should be running. When Kubernetes notices that the number of pods is not the right one, it tries to self-heal the deployment automatically. Once the unit is in active idle state, as is right now, then the pod is running properly. Okay, so this is the first part of the demo of the ETSI. Now let's go to the second part, that is the high available charms. Charms are used in OSM to run day 1 and day 2 operations on the network services. So we are going to create a network service where one of the charms is in ETSI. So if one of them fails, then the other can still operate the BNFs. So we have already uploaded the packages, the BNF and the network service packages. If we check it, this is the network service package that we want to use. So now let's instantiate the network service. Sorry, I need to go to the right folder. Okay. So while the network service is created, I want to show this config file that is added to the network service to change the network service at its specific time. We provide some configuration that we want to add to the network service when we instantiate it. So let's look at it. As you can see, it's very short. And this config unit, what we are telling here is that we want 2 units in the charms that are in the BNF index 1. So the charms in the BNF index 1 will be in ETSI. So let's have a look to the network service to see the status. Okay, this is still in building status. So let's move to the model that the VCA creates for each network service. And now let's monitor it. Okay, as we can see, we have 2 different charms, and this one that is highlighted has 2 units. So this is the one that is going to be in ETSI. You can see this asterisk. This means that this one is the leader. So this is the one that is going to execute the actions. So what we are going to do right now, we are going to delete this container, this LST container. So the second one, we will take the lead, and we will execute one action with that with that charm. So while this is right now in active status, so we can remove it. We can remove the leader. The leader is in machine 1. So this has been removed, and now we need to wait a little bit until this one becomes the leader. So with the action, what we are going to do is we are going to create a new file in this BNF. So let's try to enter in the VM, so we can double check that it's working fine. So this is the IP address. Let's look what is in this folder. Okay, meanwhile, this has already become the leader. So now we can execute the action. So we are going to create a file that is named my second unit. You can see here that the action is executing. It has already been executed. So if we double check here, we see that it has been executed successfully. We can also check the status of the operation with this OSM command, that is ns uplist, and we can see that the action has been completed. Okay, so this is the first demo we want to do for high availability. Now let's move again to the presentation. Okay, so now we are going to talk about the next generation UI. OSM Release EIGHT comes with a new user interface, and this user interface provides a fast and smooth end user experience and new functionalities. This application has been developed in Angular version 9 and has multi-language support. Right now, English, German, Spanish, and Portuguese are available. It can be easily reskinned to meet end users look and feel. Supports the most important browsers as Internet Explorer, Edge, Chrome, or Firefox. It can be scaled, allows the use of RBAC, reduces the need of manual inputs with the use of drop-down menus, and also provides a new dashboard that gives information from the BNFs that are running on, or in a failure state, or the number of packages that have been uploaded in the system. So let's go to the demo right now again. So first thing we are going to do is to log in. Okay, we are in the dashboard, and as you can see, we have one running instance, is the one that we have just created. We don't have any failed instance. And here at the bottom, we can see the network service and BNF packages. We have also the instances that we have in the system, and also the BIM accounts. If we click here, we will go to the menu, for instance here for the BIM accounts, So we are redirected to this main, to the Vim account. And here we see that we have 3 different Vim accounts, and all of them are in operational status. We have a cool feature also with this UI, is the map view, where we can see where are our VIMs located. And well, here in the left, on the left, you have all the menus. I am going to show some of them, just instantiating one network service. So for that, the first thing we need to do is to upload the BNF package. For that, it's very easy. We just need to drag and drop. So we take the BNF packages and do drag and drop. And here we are allowed to edit the BNF descriptor. We can do changes here. And we also have a read-only mode, just in case we want to read the descriptor, but we don't want to make changes accidentally. So if we click, we cannot change anything. And also, the descriptor can be seen in YAML or in JSON, as we prefer. So once we have uploaded the BNF package, we will do the same for the network service package. The same is just drag and drop. We can also edit the descriptor, and we can also instantiate the network service from here. But this also can be done from instances, network service instances. So we're going to do it from here, new network service. We have the network service name, the description. We have a drop-down menu where we can choose the network service package we want to instantiate. We will use this one, Cloud Init 1. And also, we can select the Vim where we want to use for the instantiation. We also could add SSH keys to the DNS, and we can paste it here or just browse it. And the same for the configuration. We can place the configuration for at this transition time, or we can upload a file. This we are going to paste it, and now we just click on create. Okay, so this will take some time to be deployed, but meanwhile we can also have a look to the BNF instance. Here you can see the BNFs that has been instantiated. So also you can see which is the network service that each BNF belongs to. You can check that with this ID. And in the right, we have this information button where you can find some more information about the DNF, like the DDUs, interfaces, and well, this one is the one that is being deployed, so you cannot see the IP address yet, but we can do it at this one, where you can see the IP address. Okay, so if we come here, we can see that the Cloud Init has been already instantiated. And another thing that can be done from this network service instances menu is to execute the actions. We are going to do it in the previous sorry, in the previous network service we created. So we click on exec primitive. We just need to select the primitive type, in which level is the primitive defined. In our case, it's defined at BNF level. The BNF member index, we will do it in BNF member index 1 to use the same one as before. And here we choose the primitives that are available. We have just one, that's the touch one. Now we have this, we can add the params that we need. In this case, it's file name. And here we set the value. And now we just have to execute the action. We can check if the action has been executed successfully, and looks like it is. And here we can check that the file is there in the VM. Okay, so this is the second demo. So now we are going to change again to the slide. And we are going to talk about quotas. So this feature was born to limit the resources that a project could use. So quotas are set per project, not per user. And this makes sense because a user can belong to many projects. They can be applied to all items managed by project. That is almost everything in OSM, with the exception of the user projects and roles. In case a quote is not specified, there is a default large one. And during the demo, we will create a new user and a new project with quotas set on it. So then we will map the user to the project, and we will see that the quotas applied don't allow us to use more resources than the one specified in the project. So let's do the demo. Okay, so for that, the first thing we are going to do is to create a new user. We are going to name it quota user, and we are going to provide a password. Okay, next thing we're going to do, let's create one project. We're going to call it Quota Project. And here you see that we can set the limit. So if we click here, we can specify all these values. So we are going to set a limit of 2 BNF packages, a limit of 1 network service package, for instance, and 10 for all the other values. Okay, we click on create. And now we will map our quota user to the quota project assigning also one row. So we click on Add Mappings, select Quota Project. We are going to be System Admin, for instance. And we are going also to add this user to the admin project. And well, we can be also the System Admin. Okay, so right now we can log out and log in as Quota user. Okay, you can see here that we have been logged in as admin. So if we click here on instances, for instance, we can see the instances that we created in the past. But we can change the project here. So we will switch to Quota Project. We need to specify the password again. And now you can see that we cannot see the local service instances or the packages that we have in the admin project, because project provides us isolation. So now we're going to add some BNF packages to see if our quotas works. Okay, we have added one successfully. Let's add a second one. That is successful. Our quota was of 2. So let's see what happens when we add a third one. Okay, we see that the quotas, so we are not allowed to do it. So this is all the demos for the system quotas. Now let's move to the system monitoring. Let me change in here, and I will pass to my colleague Gianpietro that will present this part.
Thanks, Guillermo. Well, as you can see in the system monitoring of this that open source MANO implements, we are monitoring more than the open source MANO itself. We are monitoring the core of the underlying Kubernetes cluster, and we are monitoring also the underlying host, the physical resources, so that we can have a complete view of what's going on in the system regarding the resources that we're using and the resources that open source MANO is consuming. I will share my screen to show you this in action. Okay, so here we have a Kubernetes-based installation of open source MANO, which brings these capabilities. And if you access the same host, but in the respective port for Grafana, we will see that as soon as you installed the open source MANO system with the monitoring capabilities, there we will have some extra dashboards already prepared. So for example, we will have dashboards for the Kubernetes cluster metrics. We have dashboards for the open source MANO system itself. So we will be able to see the end-to-end picture of how resources are being consumed by our platform. For example, in Kubernetes, we can see things like the pods, and we can navigate per namespace how many resources each pod is consuming. For example, we can see the system namespace, and in here we can see, for example, the DNS or whatever pod we want, and see how many resources is taken. Also, if we go back and go to the group of open source MANO application metrics, we can see metrics for the hosts, the physical hosts, the Kafka bus databases, and this is my favorite, the status summary, because it gives you a complete view in a single dashboard of what's going on in OSM. So this is only the pods for OSM. Here we have one of the pods down. That's because this particular dashboard is not up to date with the latest NG UI, but you can easily change it to match the environment you have installed. So that now it's up. Okay, so that's what the system dashboards are providing, and this is just an extra knob, an extra option when you install OSM in any system. Okay, so now we are going to see the last section, which is show you how to deploy a network service on top of OSM, and we are trying to show a real use case based on available open source projects. In this particular case, we're showing an Evolve packet core based on the project Magma, which is an open source implementation of an LTE packet core dedicated right now to fixed wireless access use case and being implemented in production nowadays for distributed kind of deployments. First of all, would like to review this new feature mentioned at the beginning, the OSM BNF Catalogs feature, which we will leverage for this particular demo. As you can see, the idea of this feature is to have a way to automatically grab BNF packages from any repository, any remote repository that, for example, a BNF provider can share. And in that way, it simplifies the distribution of BNF packages. And not only BNF packages, but it also applies to network service packages. So in real life, an operator that would like to test or to implement a BNF of a particular vendor would just need the link of the repository of that particular vendor, and the system will directly interact with that repository to download the BNF packages and upload them to the catalog. So we think that this feature will reinforce our vision of having unique BNF packages per function, and will also help simplify the onboarding process and reduce efforts that are being repeated again and again sometimes when people work on the onboarding of a specific function. So we will see this in action. But before jumping to that, I will describe what we are going to deploy today. What we are going to deploy is a fully operational Evolve packet core in minutes. And as I said, it's going to be implemented with Magma, which is an open source project that implements a distributed packet core. So it has two main components in purple here. The virtual EPC, which you can see to the right. That virtual EPC is a virtual machine that runs the MME, S-gateway, and P-gateway functions. Then to the left, you have the Magma Orchestrator, of what we call the EPC manager, which is a set of Docker containers that are to be deployed into a Kubernetes cluster. So this is a CNF, or a KNF, as you want to call it. So these two are the main components. We could say that the Magma Access Gateway to the right is the EPC that is deployed in a distributed fashion, so you can have hundreds of those machines if you want across a country covering a population in a distributed way. And you have the EPC, which lies in a single data center, for example, in an HA deployment that will manage the functionality, will configure, and will collect metrics from the access gateway. So what's the role of open source MANO in all of these? Open source MANO, and you will see it in this demo, is able to take network functions like these that are hybrid, and with this we start to address a question that is there from the audience on how we deal with hybrid network functions. So we can have these two elements defined in a single network function or in a single network service by using the same open source MANO information model. And also we can leverage existing Helm charts and reuse them to deploy the CNFs, which will be the case. You can also see in the picture that we are grouping the Magma components in different other network service. For example, the EPC manager to the left is a single network service on its own, but the EPC itself on the right shares the BNF package with another VDU, which is an emulator. This is an open source emulator of an eNode B and a UE based on SRS LTE stack software. We can also see a box to the left in green, which says physical router. This is a PNF. So our environment includes a PNF, which is a router that acts also as a firewall. And we are including that in our network service of the EPC because we want to touch its configuration. We want to send commands to that router as part of our network service. And you can see that everything is grouped in a slice because we want to deploy this at once, but also have the capabilities of sharing some of these network services with other slices. And we will see that the network service that we are going to share across the slices is the EPC manager. So at the end, you can have different network slices that deploy the EPC itself in a distributed way and share the same EPC manager for all of them. We also have, as you can see to the right, we have a high performance data plane box there that indicates that we are requesting the Magma Access Gateway and the emulator of the eNode B to be connected to SR-IoT interfaces, but also we are providing the configuration to the underlay network, the physical switches that interconnect these SR-IoT ports. So we do this through the SDN Assist feature that you will see also as part of the demo. Okay, so let's get started with it. I'm going to share my screen again. So we saw the system metrics, and now we are switching to open source MANO. I'm going to log in. Okay. As you can see, we have in this packages catalog, we don't have any package yet. Not network service package, no DNS package, no network slice templates, and of course no instances. We just have the infrastructure ready. So we have integration with an SDN controller, which is implemented with ONOS. We have an integration with a Vim account, or a couple of them. we have a integration with a Kubernetes cluster already, and a Kubernetes repo as well that will help us grab the Helm chart that we will need for our CNS. So all of these integrations are done with a single command. It's very easy to add a new element. You just need to know the credentials of the API, and that's it. Okay, so starting with this, we can see in Grafana, for example, some application level dashboards that are also available there. So for example, here we have the project status that will, in this case, is for the admin project, that will show us what we've got. We can add more things here, but basically what we're showing in this example is the beams and the status of the beams. And we will eventually show the network services as they appear and the status of the virtual machine. So now, imagine that some vendor give us access to the Magma BNF package together with the CNF package and the network services as well for us to test. So how would we integrate that? First of all, as I mentioned, we need to have access to that remote repository. So I will show you here how a repository of that hosts DNS looks like. Anyone can host a repository like this. This is a repository that is located at ETSI. So you can see it has an index, and it has DNS in a BNF folder. Here we have some BNF of our interest, the PNF, the EPC BNF, the KNF or CNF, and there we can have versions and the package itself. So any vendor can share this with us. So now, as soon as I have the link, what we need to do is just add the repository. You can say that it's called LTE BNFs and type OSM packages, the URL, and description. Let's say LTE BNFs and network services. Add. Okay, so I have my repository there, and now I will switch to the command line. So that I can interact in a more detailed level with this repository. Because at this point in time, since this is a new feature, there are some things only available in the CLI. Okay. There we go. Okay, so what we can do here is, of course, list the repositories. We can see both OSM types, or I mean DNS package type of repositories or Helm chart repositories. We can see the functions that are in there. So for example, running this command, OSM NF package repo list, we will see the network functions that are in the repos that we have, or we can see the network services as well. So that's already, OSM is communicating with that remote repository to gather this information. But the best thing is that we can instantly say, I want this particular DNS in my system, in my catalog. And for that, I can use the OSM NF package create command that I use with any local package. I can use it with the repo option, and providing the name of the repo, so that we can add onboard into the catalog a remote package. So I just onboarded the KNF without any effort, and I will do so with the other two network functions. Okay, so this is communicating with the vendor's repository and uploading that into my system. I will do so with the network services as well. Usually, a network operator will have their network services in a local repository, for example, because network operators are the ones that are responsible for those kinds of descriptors, the network service descriptors, and the DNS would rely in different remote DNF repositories. But here, for simplicity, we have everything in a single repository. Okay, so now let's see again our system. We have in network service packages the two network services that I explained in the figure. We have the three DNFs, the KNF. We have the PNF, which is a data center gateway, and we have a DNF that comprises two BDUs, which are these two, the packet core itself and the emulator. So we have everything we need, and I told that everything is grouped inside a network slice. So now it's our turn to create a template for that slice. That cannot be held in a repo because it's something that is designed by the operator. But so I'm just going to go ahead and drag and drop the template. If you want to see the details, we are just saying, basically, we have two subnets in the concept of network slices. Those are network services. So we have two network services. One is the Magma Access Gateway, which is the packet core, and the other one is the Magma Orchestrator, which is the EPC manager. And the interesting thing is that the EPC manager is shared, and you will see how that works in a short while. Okay, so other interesting things, for example, in our BNF package of the EPC, we are doing a lot of things. We are describing a lot of behavior here beyond just referring the compute resources that are going to be consumed. We are specifying SROB interfaces for certain connection, the S1 connection between the node B and the EPC. We are specifying some actions to be run initially as day one primitives. For example, we are going to automatically add a network. We are automatically registered to the orchestrator, to the EPC manager. We are adding a test subscriber for running some traffic tests with the emulator. We are also having some day two primitives to run some of these actions during operations after instantiation. We are also collecting some metrics from the infrastructure, configuring some alarms for this BNF. We are also in the emulator, which is this BDU here. In the emulator, we are adding primitives for attaching IUV, so that is going to let us test the end-to-end traffic, providing some details of the testing SIM card, and some network settings, and also we are using a new feature that will allow us to collect SNMP metrics. And providing some auto-scaling functions. So it's a pretty complete scenario, this one, and it's also available for the community. Okay, so we have everything. We just need to launch our network slice. Instantiate NS. I will put here a name, Magma EPC 01. Magma EPC, number 1. Select a Beam account, and I'm going to provide some initial parameters, which I have already defined here. Basically, some adaptation of the network functions to our infrastructure, because of course, as Francisco-Javier mentioned at the beginning, we have unique packages provided by the vendors and network service packages designed by the operators, but then you may want to adapt some of the characteristics to your local infrastructure, and you can do it easily with a YAML file. And here it shows like a JSON, but it's easily editable through a YAML file. Okay, I'm going to create this. And a lot of things will start to happen. First of all, a KNF is going to be launched in our Kubernetes cluster. So I'm going to visit the Kubernetes cluster. I'm going to also visit the OpenStack Vim. Okay, in the Kubernetes cluster, what I'm going to go to my namespace to see what's going to be what is being deployed there. Okay, it's converging. It's 20 seconds in, deploying a lot of pods. We can see around 10 pods there. Replica sets, stateful sets, services that is exposing some services, some dashboards there that we are going to visit. In the OpenStack Vim, we are going to see the VM part, the DNS. So as you can see, we have two components there, the Magma EPC and the emulator. This other one was already there. This is the router that we are emulating as DNS. So if we want to see this in a network topology, there we go. We have the two elements interconnected and connected at the same time through the SGI interface to the PNF. An interesting thing here is that both elements are interconnected through an SRIOV interface of type VLAN. So this connection is exposed to the fabric, to the switches. So, but they are connected. I mean, these two elements need to connect between each other, but they need to go to the physical fabric to have better performance through SRIOV. So we need to also take care of the switches that are in the data center. And we do so with an SDN controller that is already there integrated. And I will explain this further, but OSM notices that there is a connection that needs to be done. And what it's going to do in these three switches is configure some flows to, in this case, we are doing it with OpenFlow. We can be done with VXLAN, other mechanisms, and make sure that the VLAN 1096 is being interconnected along the path. So for example, if we visit one of these switches, we will see that VLAN 1096 is there. There is a flow end-to-end for interconnecting both elements. So back to the cluster, to the Kubernetes cluster, I'm going to see if everything is ready. Okay, everything is ready at the KNF level. So that's going to give us some visuals of the PNF we just launched. I'm just going to grab the IP address of the Nginx proxy, which is the EPC manager dashboard. And it's going to be automatically configured with the day one primitives that I show. So if I access it, it doesn't have any network configured yet. That means that it has not been configured yet. So we will have to wait a little bit for the system to converge. So now it's running the day one primitives, and we can see maybe here, if we see that it's still working on the primitives, on the configurations, the resources have already been instantiated. So what it's doing now is running these primitives. We can see that it's still going on. In the meantime, we can see, for example, here the network service instances as well. There is a connection between the new dashboard of OSM and the metrics that are provided in FANA per network service. So if we click in there, it will open a new dashboard that has been just provisioned to show the metrics of the network service. So as you can see, we are grabbing here CPU, we are grabbing memory, and also network traffic. This is collected from the hypervisor, I mean, at the OpenStack level. But we also have the capabilities, and this is a new thing, to collect SNMP level metrics. So if we go to this SNMP exporter dashboard, we will start to see some metrics appearing here for the EPC. So this will give us a lot of possibilities to auto-scale based on these metrics and do some alerting, some traps collection, a lot of things, because we have seen that most BNFs, production-ready BNFs, big BNFs, still expose the metrics through SNMP, so that's why we're doing this support. Okay, let's see how primitives are going on. I'm going to show you the terminal again. Okay, so the primitives are ready. So now, if we visit the dashboard again, what was unconfigured, we will see that it's configured now. It has a test subscriber. It has an integrated access gateway, so everything is ready to receive traffic. So what we're going to do now is to attach a UE, and for that we had, so everything is ready. So for that we had a primitive. I'm going to execute a primitive, which is just an action. This is a day 2 primitive because we are running it after instantiation. At the BDU level, in the Magma access gateway, in the emulator, we will select the attach UE primitive and provide the values of the SIM card. So the IMSI, the key, and the OPC, which are the standard parameters of a SIM card, we are providing the values that are configured in our test subscriber. Okay, execute. And this, what it's doing is running a primitive inside this element, which is the emulator BDU. So I'm going to access it. Okay, and what I want to show you is the routes. So soon this will connect to the access gateway. It will create a GTP tunnel, which is a IPv4 on top of GRE. There it is. And we will have connectivity to the access gateway through the SIOB interface. There you go. And we should also have connectivity to the internet through here. We can see that that's not the case, and that's because we have a router in place. So we can also send a primitive to the router to allow us to pass. So in this case, you are communicating to a PNF and configuring the PNF, providing the Magma IP address, which is, let's see. Of course, we can automate this as well, but we wanted to show some examples of the process. Okay, this is the IP address. So execute, and that sends a communication to the router, to this router here, to allow the traffic from the UE. So in short, this this virtual machine that emulates a UE, a smartphone, will have internet connectivity. There you go. So now, well, we can see that traffic is flowing through the application and through the fabric, I mean, to the physical switches that we have at ETSI. There we go, we have some packets, small amount of traffic now in this demo, but you get the idea. Okay, so the last thing I would like to show is that you can, well, it's actually getting into the details of what we just saw, and especially focusing on the SDN assist feature that we showed, because this is very important, relevant for high-performance BNFs. You can see that BNFs can be exposed to the fabric directly through SROB ports, and open source MANO through SDN controllers, through config managers, can configure automatically this fabric, this amount of switches, to interconnect between, to interconnect the SROB ports that are relevant for my network function. That's what it is providing. And as of Release 8, as Javier mentioned, the Arista, Cloud Manager, Juniper Control, Cloud Light, ONOS, and Open Daylight are supported. Okay, so what we wanted to show you here is that Zero Touch is here. You can see an end-to-end network service like this can be automated and ready to serve any network function can be treated this way. And this was a relatively simple DNF. I mean, it's complex, but if you compare it to other packet cores, 5G workloads, it can be considered simple. And so as functions get more distributed, more modular, and they have more components, then NFV orchestration becomes a must. As you can see, we have to automate everything. And OSM provides, as you saw, a rich BNF onboarding capabilities. We can automate all the process since obtaining the BNF package from the vendor to delivering the final service. Everything is modeled. Okay, so thank you for your time. Now we will answer some of the questions of the audience.
Okay, thank you, Gianpietro. I mean, we have 2 minutes before closing the webinar, so I think that we need to be quick. I mean, there were some questions from the audience. For hybrid network functions, BNS and CNF, we want to have almost similar model in terms of BNFD and SD as much as possible, but today it's not happening. In fact, many vendors for their 5G CNF onboard them directly using help packages. We want to know what is your view on this, and we can solve this issue. Maybe solve 1, solve 4, need some coherence. Well, so what is our take? I think that you answered this already, Gianpietro, but if you want to elaborate.
Yes, so we are using the same model for PNFs, CNFs, and BNFs in OSM. And of course, CNFs have an extra complexity that is well addressed by Helm charts, and in fact, that's what the approach that ETSI NFV standards is taking. So OSM can get any Helm chart, or you have another mechanism through UU bundles to deploy any given workload. So if a vendor already has a Helm chart, it can easily be integrated into an OSM descriptor just by referring the Helm repo and the name of the chart, and that's it. So I think we are very well adapting to what the industry needs.
Okay.
Excuse me.
Right.
I'm afraid I have to butt in here because the time for the webinar is now closing. What I can confirm is that the 2 questions that remain, we will reply to you by email after the event, so don't worry. I just want to say thank you very much to all the speakers and presenters and for their time. And I think that they have given you a very good overview of the whole OSM 8 Release 8 process. One thing I would say before I close the webinar is please keep an eye on the Bright Talk channel, as we're making webinars on a regular basis. And I just want to say goodbye and thank you very much.